All right, in this video, we're going to try to find a couple of features of these sinusoids given the graph, in particular the period, amplitude, and midline. And this will prime you to finding the equation, which I'll do in a later video. But for now, let's just hone in on this skill. So I've got three graphs here, and I want to just find these three things. So first, just a reminder of definitions. If you're coming to this with perhaps without the prior video, I'm assuming you've learned what period is. The period is the length of one cycle. Okay, now period has a more technical definition, but for our purposes, it's the length of one cycle. In other words, it's how long, where I'm using the word long in quotes, how long it takes for this graph to repeat. The amplitude you want to think of as it's the maximum value minus the minimum value divided by 2. And to see what I mean by that is visually, amplitude should conjure up ideas of like, sound or it's kind of a synonym for sound in many cases, or the volume of a sound. But well, actually, before I do that, let's define the midline, and then I'll explain why these make sense, because I'm not going to draw on the midline before I define it. The midline is the average. The word mid should make you think of middle, which is in often cases can be defined by the average. It's the average of the max and the min. So max plus min divided by 2. So let's kind of apply those here. Let's start with period, right? This graph clearly repeats over and over again, and I see a max value there, and then I see another max value there. The period is just that distance, which we can see is, well, the graph starts here at 0, or the point we care about starts at 0. It ends at 4 pi. So 4 pi minus 0 is equal to the period. Okay, so the period is going to be 4 pi. It's key to note that you can find that, and you didn't have to use those 2 points. You could have used these two, right? Like that point right there, that's at pi. In fact, let me label that coordinate. That is pi negative 5. And that appears again right here, right? The corresponding point appears there. That's 5 pi negative 5. By thinking of subtracting x coordinates, we can see that the distance is 5 pi minus pi, which is 4 pi. So the point is you can get the period. As long as you use any two corresponding points, you'll get the period. So that takes care of period. Let's look at amplitude. Actually, first let's do the midline. The midline is probably easier because then we can draw it. The midline is equal to, well, first of all, the midline is a, I should have noted that the midline is a line, so it has an equation. So it's y equals whatever that value is. It's a horizontal line. So the midline is the max value plus the min value divided by 2, or the average of the max and the min. So our max value is the highest y value we see. I note that that's negative 4, and that is the highest y value. So the max is negative 4. The min is down here. That's negative 6. The minimum y value is negative 6. We average those two, and we get negative 10 over 2, which is negative 5. So the midline is y equals, I don't want to be sloppy here, the midline is y equals negative 5. Okay, it's an equation, and I'm going to dash it in here. So it's called the midline because it goes right through the middle of the graph, which leaves us with amplitude. So amplitude is, what I was trying to get at earlier, is amplitude is basically the height of a wave from the midline. So this distance here, right, that's the amplitude. And the reason this formula works is because max minus min is a vertical distance, right? Max minus min is just a vertical distance. And when you cut that in half, as we're doing up here, when you cut that in half, you're going to get half that distance, which is also the distance from the midline to either the max or the min. So our amplitude is max minus min. So our max is -4 minus -6 divided by 2. And that equals, oops, sorry, jumping ahead. That equals, so this becomes -4 plus 6, which is 2. So that's 2 over 2, which is 1. So the amplitude is 1. And clearly you can see that's what this distance is here. Because if this is -5 and that's -4, then that height is a 1. So let me do this the next few examples in maybe a little more streamlined. Let's get ourselves set up over here. So we're going to start with period. I'm going to write in the I'm going to write midline first because I think that's just something I want to find first. And then the amplitude will do third. Okay, so to find the period, again, note, let's make our lives easy and just note that this graph goes right through the origin, right? So that point right there is a good place to start. And then you note that it repeats. Now the repetition is going to happen. In fact, let's highlight it. There's one cycle there. Now, actually, to be honest, it's not clear. It's not actually that clear where that is, right? So let's try to find the period in a different way. So I'm going to notice that it just did one cycle, right? So that's one cycle. We don't know what this is because it's not obvious. So I'm going to put a question mark there. But it does another cycle there. It does another cycle there. So it does 3 cycles. So it does 3 cycles every 2 pi. Okay, so that's another way of saying what the frequency is. Okay, so the frequency means how often you do something. So this does 3 cycles per distance 2 pi. Okay. So what does that mean? Well, it means that if it does 3 cycles every 2 pi, it must do 1 cycle 2 pi divided by 3. So it must do every 2 pi divided by 3, right? Again, if it does 3 cycles every time you travel a distance of 2 pi, and if you divide that into thirds, if you divide 2 pi into thirds, you'll get how long it takes to do 1 cycle. So we see that its period is 2 pi over 3, and you should note, if you didn't see it from here, or if you didn't see it from this video, from another one, that the frequency, what's called the frequency, is the opposite, is the reciprocal rather, of the period. So our period is equal to 2 pi over 3, which is the reciprocal of the frequency. The midline is max minus min divided by, max plus min divided by 2. The max is clearly 1. Just note the scale here. Right, so our max is 1, so 1 plus -1 divided by 2 is equal to 0. So y equals 0 is the equation of the midline. And then the amplitude is 1 minus -1 divided by 2, which is equal to 2 over 2, which is equal to 1. So we got our period, midline, and amplitude. And again, notice that the amplitude is confirmed. It's this distance here, which we could have seen visually as a 1. The way it's important to use the calculation because sometimes these maxes and mins are not in places that are so obvious. Let's finish with this example here. I think I'm going to add a little page just to give myself a buffer in case we need more room. Let's get some of this writing out of the way. Okay. Okay, so let's start with the period. So these intervals are nice. This is 5. They're going up by 1. That's clearly a 6. I see a point there. I see a point there. That horizontal distance is clearly 6, so the period is 6. The midline is going to be y equals the average of the max and the min. So if this is 5, this is clearly 9. So it's 9 plus the minimum, which is -1, divided by 2. So that's 8 over 2, which is 4. And if you dash in y equals 4, you should see that goes right through the middle as we would expect. And in this case, you could find the amplitude by just noting the distance from the midline to a max, right? If this is 4 and that's 9, then this is clearly 5. But let's just double check it with our formula. So the amplitude is equal to the max value, which is 9, minus the min value, which is -1, divided by 2. But that's 10 over 2, which is 5, which is what we guessed. So period is the length of one cycle. You can find it by finding the distance between any two corresponding points. Amplitude is max minus min over 2. It's also the distance from the midline to a max or a min. And the midline is a horizontal line, which is the average of the max and the min.